Welcome to the sixth and final video in Chapter 4 of the Pearson video series. This lesson discusses overlapping triangles. Overlapping triangles can make your head spin around when you are trying to determine what corresponding parts are congruent. Unless you are a spatial visualization wizard, your first step should be to redraw them. Let's take a look at triangle FHJ and triangle KHG. So if we separate them, it doesn't have to be anything perfect, just so that you can see what you're working with. And I want to go ahead and label them as well. So let's see, this is F, this is K, this is H, this is H, this one is G, and this one is J. Okay, so now we have them separated. Once you separate them, then you can kind of see which ones are congruent. So we have K and F marked congruent, and H is congruent to itself. Okay, and then we've got FL and LJ marked congruent to KL and LG. And if we add those together using the segment addition postulate, then we get both of those are congruent to each other. So we can go ahead and mark those. Okay, so we have angle H is congruent to angle H. We have angle F is congruent to angle K. And we have side FJ congruent to side KG. All right, and looking at that, these two were given to us. So this one was given. This one was the segment addition postulate. And angle H is congruent to angle H because of the reflexive property of congruency. So when you take all of that together, we can say that these two triangles are congruent based on angle, angle, side. So there's kind of a casual proof for two overlapping triangles. Now let's take a look at a regular proof. Okay, so we have these two triangles here. We have EGD and we have EFH, and those are overlapping. You can kind of tell that they're overlapping. So let's see what we can do without redrawing them. So DF congruent to HG. So here's DF and here's HG. Those are both marked congruent. I'm going to mark them again so that I can tell what is marked, and we're going to call that given. And then we have FG right here is congruent to FG. So we're going to mark that one. We'll mark it with 3 since these are already marked with 2. And that's going to be the reflexive property of congruence, because anything is going to be congruent to itself. Okay, and then we have DG, which goes from here to here, and FH, which goes from here to here. And I've got two congruent segments and a segment that's congruent to itself. So we can say that those are congruent because of the segment addition postulate. All right, then we've got another given. So if we look to see what else we're given, it looks like these two lines right here. So we can say DE is congruent to side HE. And that's given. All right, then we have something because of the isosceles triangle theorem. Okay, so if we have an isosceles triangle, which we do because we just said that these two sides were congruent. So if we have an isosceles triangle, then we also know that the two base angles, or the opposite angles, so this angle is opposite this side, and this angle is opposite this side, are also congruent. So we're going to say angle H is congruent to angle D. And that's because of the isosceles triangle theorem. All right, now we've got two triangles that are congruent. So EDG and EHF. So let's take a look and see what we've got. So if we just look at one of the triangles, so let's take a look at, let's just highlight one of the triangles so we can see what is marked in that triangle. So here's our triangle. Okay, and if we take a look at that, it looks like we have a side, an angle, and a side. So we're going to say that those two triangles are congruent because of side, angle, side. And then, because we know those two triangles are congruent, we want to say that angle EGD, which is EGD, so this inside triangle right here, is congruent to this inside triangle right here. And that's going to be true because we've already proved that the triangles are congruent, which means that their pieces and parts are congruent. And so because of CPCTC, congruent parts of congruent triangles are congruent, we can say that angle EGD is congruent to angle EFH. All right, now, that wasn't that hard, was it? Go ahead and flip this over. And we have another proof on the other side because let's face it, you just can't get enough proofs. So this one I want you to try on your own. It's going to be very similar to what we just did. Think about what you've been doing with your IXLs and the reasons that you've been given. Remember, you always start with givens. And then what kind of things do you prove when you know the midpoint? What kind of things do you prove with the reflexive property? And for what reasons can you say that triangle CBE is congruent to triangle CDA? We'll take a look at this in class. All right, last thing. Let's take a look at some assessment questions because this is something else that you just can't get enough practice with. So, this first one says, which statements are true? Select all that apply. So, go ahead and pause the video and decide which ones you think are going to be true. And then take a look at this SAT, ACT question and decide which one of these is true. Keep in mind that both of these are easier if you can eliminate some answers that you know are not going to work. As soon as you've decided what your answers are, then go ahead and start the video and check your answers. All right, so if we look at this, we can tell that angle KJN, okay, KJN is congruent to angle KLM. And MJ is congruent to NL. And these two triangles are congruent. And if you haven't figured out why they're congruent yet, it's because of side, angle, side. All right. This other one, we know we can mark out side, side, side right away because we have no sides marked. And angle, angle, angle never works. And that's never going to be a reason for congruence. Later on we'll use it for similarity, but never for congruence. Which means that we have side, angle, side, and angle, angle, side. So we have to figure out what we can use. So if we take these two triangles apart, then we're going to have one triangle, ACD, and we're going to have another triangle, and that one is BAD. Okay, and we have angles B marked and C marked congruent, and we have D marked and A marked, and then we also have the big A right here and the big D right here, those marked. Okay, so we have angle, angle, angle marked. It's just not something that will prove congruence. Now, something else that we have is this line right here. AD is congruent to AD by the reflexive property. So we can say this is congruent right here and right here. And so we have a couple different things that we can use here. We can use, we can use angle, side, angle, but that's not one of our choices. Or we can use angle, angle, side. So for this answer, the best answer is going to be angle, angle, side. Okay, that's all we have. That's the end of this chapter. So work on that proof, and we'll go over it in class. See ya.